Hey, I'm Hagen, and this is the second part of my finished project 4 for QM238. So for question 2, the first thing I did was I imported pandas into Jupyter Notebook by doing import pandas as PD. I then read the CSV file which was given to us for question 2, and then saved that as a data frame by doing the PD or pandas.read CSV function. Then I plugged in the CSV file. Then the next thing I did was display the data by just putting df. So the next thing I did was check the different types of data within the CSV file. As you can see here, I did the .dtypes function, and they all came up int64, which means all the attributes are binary integers. So the next thing I did was to check for any missing values. I did the df.isNull.sum function, and as you can see here, there were no missing values. I then checked for any duplicate values by doing the df.duplicated.sum function, and there were 7 duplicate rows. So then I needed to drop those duplicate rows, which I did the drop duplicates function. And then I just went ahead again and made sure that those duplicate rows were in fact dropped. So I ran the .duplicated.sum functions again, and as you can see here, there are now 0 duplicated rows in the data frame. So the next thing I did was want to visualize any outliers. So first to do that, I needed to import the libraries seaborn and matplotlib.pyplot. The next thing I did was actually create the box plot and visualize those. So I did seaborn.boxplot, then I did pyplot.show, and it gave me this graphic. And as you can see here, obviously most of the outliers are in the lot area attribute. So the next thing I need to do was to drop any outliers for lot area. I defined the first quartile, the third quartile. I then defined the interquartile range and set the threshold as 1.5. And then I defined all my outliers based on the interquartile range and the threshold. And then lastly, I dropped those outliers. The next thing I needed to do was to create a statistical summary using df.describe. Okay, as you can see here, the count tells me how many for each data type. Let me go back and run this because it's doing the clustered. Okay, so it gives me the count, the mean, the standard deviation of the data, the minimum in each attribute, the first quartile, the median, the third quartile, and then the maximum value in each one. For my statistical summary when I ran the .describe function. I then created a scatter plot by using seaborn.scatterplot function. So for this, I decided to put lot area as the independent variable. I did overall quality as the dependent variable, and then for my hue, as you can see here, I did the overall condition because I thought those would be the 3 most important features in the clustering. And as you can see here, there were various different things throughout this scatter plot. It wasn't necessarily more linear like the other scatter plots you've seen in the past. So the next thing I wanted to do was to standardize my data. So I imported NumPy. I then imported standard scalar. I defined x as the different values in my data frame, and then I standardized x by using standard scalar and the .fit underscore transform function. Then I displayed that then standardized data set. So the next thing I had to do was to use the elbow method to measure or to estimate what would be the best K value to use for my clustering. So I can delete that because I've already done that. But I imported K means. Did I import K? Doesn't matter. I then did a calculation to estimate K by using the dot fit function and dot append functions. I then created a data frame using the previous calculation, as you can see here. And then I set up the actual data frame to plot by using the pyplot.figure function. And then I visualized that distortion rate change by doing the pyplot.plot function, the pyplot.x label function, and the pyplot.y label function, which gives me this linear graph, as you can see here. And 3 is the estimated K value, because that is my sort of elbow right here, which kind of connects the upper arm of the graph and the lower arm of the graph. Yeah, so like I said, the elbow method recommends K equals 3 to use as my cluster number. So the next thing I did was I started clustering. I set cluster number at 3, and then use clustering and sorted by the mean. So I did the dot fit function, the dot labels function, the dot select d types, which included the number values, which all of them were number values. And then I did the group by the mean function. So yeah, as you can see here, it gave me 3 clusters, which is what I plugged in. So cluster 0, or the first cluster, it consisted of the smaller houses. As you can see here, the lot area was smaller. They had less bathroom, and they were below the median price, actually. So that would be 1, 0. Yeah. So 1 was, or actually the second one was the smallest lot area with cheaper median price, and they had less bathrooms, less bedrooms. Cluster 1, this one was the median one, and this one was the larger, more expensive one. As you can see here, the lot area is bigger. It was above median price. I then define inertia by using k-means, and then I printed the amount of inertia, as you can see here, and it was still a relatively high number, but it was a lot lower than the inertia I got in question 1. And like I believe that this was more effective because I had a lot more different attributes to cluster based upon. And I think it did a good job overall at clustering, so I would say that this was effective. Thank you.